We are onto the exhaust system. So as usual, this first episode is a general overview, and then in subsequent videos, we'll dive into the details, all the various components. You maybe noticed what we've done is we've skipped from the air intake system straight into the exhaust system, and we've gone past the fuel injection system and the ignition system. There's a reason for that. There's logic in the madness. The reason is that the sensors on the exhaust system are really the critical sensors that determine the fuel injection process, how much fuel is injected into the engine. So we need to fit the exhaust, and we need to talk about those sensors before we can go back and talk about the actual combustion process that generates these exhaust gases. So what does the exhaust actually do? Well, fairly obviously, it brings the combustion gases, those waste gases from the combustion process away from the engine out to an exit point, generally at the rear of the vehicle, the tailpipe. Now, why do we need to move those gases anyway? Well, they're toxic, they're hot, and they're corrosive. So we want to get them away from occupants and also away from any sensitive mechanicals. We don't want them blowing around in the engine compartment. So the exhaust system brings those gases away and out of the vehicle to the atmosphere. But along that journey from point A being the engine and point B being the tailpipe, from A to B, we also do some work. So the exhaust needs to do a few different tasks. One of those tasks is to modify the noise of the exhaust. It also reduces emissions, and it should hopefully enhance the performance of the engine. So we'll look at how it does those three things as we go along and talk about these various components. Now let's see what the exhaust system actually consists of. We've got on the engine side, we have a heat shield here. Now, this heat shield protects the air cleaner box here, which is made of plastic, from the heat of the exhaust system. So let's remove that air filter box so we can actually see what's happening. This is our heat shield, which protects the air box. Let's pop that off. You can see underneath we have the exhaust headers. So the exhaust gases come out of the cylinder head here through these exhaust ports into the headers. So at this point, as the gases come out there, they're about 800 degrees Celsius, which is about 1500 Fahrenheit. They make their way along this pipe. As they come along, they cool down. So once we hit the catalytic converter here, those gases, once this system's up to temperature, they're going to be about 450 Celsius, about 800 Fahrenheit. As we come further along, by the time we get to the tailpipe here, those gases are probably coming out about 100 Celsius, 210 Fahrenheit, something like that. So we have a steady cooling of the gases as they come along this system. But at this end, they're piping hot, so we need the heat shield. This is our manifold or our exhaust header, and the function of this is just to gather together the gases that come from each cylinder. So we've got 4 cylinders in this engine. We have 4 pipes, these are called primaries, that come off the exhaust ports, and you can see that these join together. So these 2 cylinders are joined here. This is a collector, and they join into one pipe and make their way down, and then those 2 pipes join into one pipe, which makes its way to the rear of the vehicle. Now, the length of these primaries, the distance of these collectors from the head, and the fact that we have 4 pipes going into 2 and then 2 pipes going into 1, all of those design factors play a role in the performance of the engine. Now that's something that we'll look at later, but it's important to know that the placement of these collectors and the diameters of the pipes and the lengths of these pipes does have an impact on the performance of the vehicle. From there, we move down. So what do we have on the header here? Okay, we have a component on this side of the header, which is the EGR pipe. So we have a small pipe that runs off the exhaust manifold, the header here, and along around the back of the engine here, back to the air intake, back to the intake manifold. And we saw the other end of that when we talked about the intake manifold. We saw the valve, the EGR valve, that controls the flow of gases along this pipe. Essentially, the EGR system takes some of the exhaust gas and puts it into the intake system, mixes it with the intake gases to reduce the combustion temperature inside the engine. We'll talk about that in its own video on EGR systems. And the main reason for the EGR system is to cut down on the amount of nitrogen oxide in the emissions from the vehicle. So as we come down the manifold here, we come to the first of our oxygen sensors. So on every exhaust system, on every modern vehicle, there will be at least one, probably 2 or more oxygen sensors. They're also called O2 sensors or lambda sensors. They're all 3 names for the same thing. So on this vehicle, this front oxygen sensor, the first one that we come to along the exhaust system, is critical in controlling the fuel injection system. So this sensor detects the amount of oxygen in the exhaust gases inside the exhaust, sends that information to the ECU or the PCM, and the computer uses that information to determine how much fuel is injected into the engine. Very, very critical sensor. Next, as we come down our pipe off the manifold, we come to the catalytic converter, or the CAT. Now, this is the most expensive part of the exhaust system. It contains precious metals like platinum, palladium, mixed in with some ceramics in there that form the catalyst for a chemical reaction, hence the name catalytic converter. So what the CAT does is it takes nasty pollutants in the exhaust gases and converts them into less harmful gases. So it takes nitrogen oxides, hydrocarbons, which are basically unburnt fuel and oil, and carbon monoxide, and it converts those nasties into nitrogen, water and carbon dioxide, 3 much less harmful, if in fact not harmful at all really, gases, which then improve the emissions of the vehicle. So the thing with the CAT is it only works at high temperature. It only works above about 400 Celsius, 750 Fahrenheit. So it needs to be towards the hot end of the exhaust, as close to the manifold as possible, because this thing doesn't work until it gets up to 400 Celsius. We want it to warm up and start working as soon as possible. From the CAT, we hit our rear oxygen sensor. So on this vehicle, we've got 2. The front one controls the fuel injection system, and this rear one, which is an identical component, albeit with a slightly different tail on it, this one measures the amount of oxygen at this point in the exhaust and compares it to the first, or the computer compares it to that first front oxygen sensor. And the amount of oxygen should have changed because the catalytic converter has used that oxygen in its processes. So this oxygen sensor really has the function of making sure that the CAT is working. If this oxygen sensor produces an identical reading to the front oxygen sensor, then the ECU is going to see that and it's going to turn on the check engine light, probably flash it to say that the catalytic converter is not working. And that's a requirement, it's a legal requirement for emissions on all modern vehicles. Various different setups of these oxygen sensors exist on vehicles, so don't be surprised if there's only 1, or in fact maybe there's 5 on your vehicle. Just know that they all perform more or less the same function, as in reading the amount of oxygen inside the exhaust system. From this rear oxygen sensor, we come along the pipe and we hit the first of our 2 mufflers or silencers on this exhaust system. So the purpose of these mufflers is to shape and generally to reduce the amount of noise coming off the vehicle produced by the exhaust. I mean, that's subject to very tight regulations. There's very specific rules on how much noise an engine, a vehicle, an exhaust system can produce, and so the silencers here have the task of bringing the noise level down. If you've ever heard an exhaust without a silencer on it, you'll know it's incredibly loud. It's immediately apparent if there's no muffler, no silencer on an exhaust. So they not only reduce the noise, but they also shape it. So manufacturers know that the sound of an exhaust sells vehicles. It sounds good. And particularly on this vehicle, Mazda with the MX5, starting with the Mark 1, they knew that a good sporty sounding exhaust would give this car more of a sporty feel, make it more of an enjoyable driving experience. Particularly when you've got the top down on a cabriolet, you're more connected with the exhaust sounds of the vehicle. So Mazda made some efforts. This is more of a resonator. It shapes the exhaust note as it works its way through the system, whereas this rear silencer here has the meat of the silencing task in it. You know, it's obviously much bigger, and it has more of an absorption, more of an effect on reducing the noise of the exhaust system. We'll talk about both of these silencers later. We'll chop them open and see actually what's inside them and how they work. Now, coming off this rear silencer, we have the tailpipe. And the tailpipe just really has the job of taking the exhaust gases from the final silencer out to the rear of the vehicle to vent out to the atmosphere. Now, something to note is the tip of our tailpipe here has a nice kind of chrome stainless effect. It's quite a stylish polished finish, because really, you know, that's the only parts of the exhaust system that you actually see when you look at the vehicle. And of course, as you see this chrome pipe, it gives the impression that the rest of the exhaust system is actually a beautiful polished chrome stainless steel, when in fact most exhaust systems are made from a mild steel with a little bit of galvanizing on them. All exhaust systems are of a sectional design, which means they're made up in chunks or parts. So on this system, we have the header coming down, and we have the front pipe, which might be called a down pipe, that comes along. We have the mid pipe, we have the rear pipe there. And they're bolted together by exhaust flanges. So each section has a flange, and those are bolted together to join the system. In between the joints is a gasket. So there's different types of gasket shaped around the actual flange itself, but on this particular joint here we have a kind of pressed gasket here, a sheet metal type design that fits into there, and on these other later joints we have a round circular gasket which is made of a kind of heat resistant material which is compressed when the sections are bolted together. In terms of fitting an exhaust to a vehicle, not only does it come in this sectional design, but it needs to be isolated from the bodywork of the vehicle. So when we talked about the engine mounts, we discussed that the engine vibrates, creates a lot of vibration, which we don't want to transfer into the rest of the vehicle. So the engine is mounted on rubber blocks, and the exhaust is bolted directly, it's a rigid fitting to the engine. So if the exhaust was then bolted directly to the bodywork of the car, we would have made the engine mounts completely pointless. We would have made them totally ineffective by joining the engine through a rigid exhaust to the bodywork. So exhaust systems will tend to hang on rubber hangers. We've got some at the rear here. They hang on these rubber mounts which isolate the exhaust from the bodywork and stop the vibration from the engine being carried into the actual vehicle itself. Now, there's different types. Every manufacturer has a different type of rubber exhaust mount. I don't know why they can't standardize on one particular design, but every manufacturer has a different exhaust mount design. Let's talk about the design of exhaust systems for a second. So when a manufacturer designs an exhaust system, there's some constraints on that design. One of those constraints is fitment. So the exhaust header particularly needs to fit and be packaged into an engine bay. It needs to route around various obstacles and make its way to the rear of the vehicle. So fitment is a key constraint. Another constraint is noise. So the exhaust system needs to achieve a certain level of noise reduction. A third element is cost. So a manufacturer needs to build an exhaust system at a certain cost of manufacturing and fitting that system. We also have emissions, so the exhaust system needs to achieve certain emissions requirements. And finally, we have performance. So the performance of the exhaust system, it dictates its design to a certain level. Now, obviously, different vehicles place different priority on those constraints. You know, certain vehicles will have a very strong emphasis on fitment, for example, or noise reduction, whereas other vehicles, perhaps performance vehicles, will make more efforts to achieve performance from a system. But the exhaust system, and in fact those different design requirements mean that an exhaust system is one area of a vehicle where a performance part can make quite a significant difference to the performance of the engine. And we're going to talk about header design and the effect that what's called scavenging, which is the way that exhaust gases are pulled through the engine. It increases airflow and volumetric efficiency. We'll talk about all of that when we discuss the header, but just know that the trade-offs between those designs affect the design and the performance of an exhaust system. One of the most noticeable things in looking at an exhaust is the diameter of the pipes. So the diameter of a main exhaust pipe is determined by the flow of air through the engine at peak revs. So the cubic feet per minute is the measure that's used for this. We measure the amount of gas coming out of this engine in cubic feet per minute at its peak, and then the rest of the exhaust system is sized around that requirement. So a general rule of thumb is that for every horsepower, there's 2 cubic feet per minute coming out in terms of exhaust gases. So this engine generates 108 brake horsepower, stock engine, stock 1.6. So this will produce about 220 cubic feet per minute of exhaust gases, and those need to be carried away along the pipe. So this is a classic, your standard size of exhaust pipe on a road vehicle is 2¼ inches. So if we measure this pipe, let's take a look here at the diameter of this pipe. We got 55 millimeters, which is about 2¼ inches. So this is just your classic exhaust pipe. Now on a V8 engine, you would find that you would have, you've obviously got a larger amount of exhaust gas being brought out. You'd probably still find 2¼ inch pipe on there as a stock fit, but you would find that you've got dual exhausts. So one exhaust coming off one side and another exhaust coming off the other bank of cylinders, and those then make their way to the rear of the car. So you've effectively got 2 exhaust systems on a V-shaped engine. So it can be tempting to think that a bigger exhaust pipe is going to increase the performance of the vehicle. It's going to move the exhaust gases quicker to the rear of the vehicle. That's actually not true. So what you find is if you have a pipe which is too big, then the velocity, the speed of the exhaust gases flowing along that pipe slows down. And if you have a pipe that's too small, obviously that restricts the flow. But it's important that there is an optimum size of pipe. It's not just a case of let's throw a big old 5-inch air conditioning duct at this thing and pump it out the back of the car and put a big old bucket-sized tailpipe on there and it's going to look really sporty. You might find a whacking great tailpipe on the end of a car, but most likely you've got 2.25 inch pipe running actually along the inside of the vehicle. Construction, the actual material that's used for an exhaust system is generally mild steel. To talk about that, let's pop out to the junkyard, aka the front garden, where we've got a couple of good examples. Virtually all stock exhausts are made from mild steel. And you'll know that exhaust systems are renowned for rust and corrosion, and you look underneath a vehicle, you see a rusty exhaust. Well, why is that? It's because exhausts have a particularly tough life. So they operate at high temperature a lot of the time, and that temperature fluctuates as the exhaust heats up and then cools down. Plus, they're filled constantly with these noxious, nasty, corrosive hot gases which cause and accelerate corrosion internally. And not only is there the hot gases in there, there's also steam. So steam is a byproduct of the combustion process, and when the engine first starts, it generates steam. That steam will build up and pool inside the exhaust system, and it will pool particularly inside the mufflers, inside the catalytic converters, until the exhaust gets up to temperature, and then obviously that water will then reboil and be taken out of the tailpipe of the vehicle. But until then, it sits inside these pipes. And if you have a vehicle which travels lots of short journeys and the exhaust system never gets up to temperature, then it will tend to corrode much more quickly because you've got this build-up of water and steam inside the exhaust system. Plus, the exhaust hangs down underneath the vehicle, so it's in contact with any salt on the road and just general water and weather all the time. So exhaust systems will tend to corrode. One way around that is an aftermarket exhaust system which is made from stainless steel. So here we have 2 exhaust systems exactly the same from this old 1987 Toyota MR2, and these are the same age. These came off vehicles the same age. This one is the stock stainless steel, mild steel exhaust system. This one is stainless steel, and you can see the difference in wear. Even on these pipes here, obviously they're a little gritty, but they're not heavily corroded and pitted and rusted like this one. So stainless steel exhausts, better, will last longer, but they're considerably more expensive. And while we're down here looking at these, you find these flexible joints on transverse mounted engines. So when exhaust fits to a transverse mounted engine, that's an engine that fits sideways. It runs laterally across the vehicle instead of along the length of the vehicle, like this vehicle here. So what we have here is a rear-engined, rear-wheel drive vehicle with a transverse-mounted engine. So you can see inside the engine runs across the vehicle. This is much more common in a front-wheel drive vehicle or in an all-wheel drive vehicle. And the reason they have that flexible joint on the exhaust is that transverse-mounted engines will tend to rock a lot more because they're driving the wheels side to side and the actual engine is spinning side to side, as opposed to a longitudinally mounted engine which has less of a tendency to rock. And if you want to get really fancy on an aftermarket exhaust, you can buy titanium aftermarket exhaust, which not only is going to last longer, completely corrosion resistant, it's also going to be much lighter than a steel exhaust, and it produces a completely different exhaust sound because of the nature of the material. So that is a general overview of the exhaust system. In the next series of videos, we're going to look in much more detail at the headers, the manifold, the EGR system, the catalytic converter, the O2 sensors, and the silencers and mufflers. So come back in the next series of videos as we get into the details. Guys, the way to learn to fix things, how to repair cars and so on, is not to bounce from video to video troubleshooting each little problem as it arises. It's to get a deep level of understanding on all the systems on a car. What you need is a complete course that takes you simply from A to Z. So, if you enjoy this level of detail, then get yourself over to howacarworks.com. We've got a whole series of videos, at least 20 hours, teaching you every part of modern vehicles. Come and join us over there.